Hello, General Chemistry. This is going to be our fission video, and well, we'll just get started. Fission is a nuclear process. Involves it's part of our radioactivity unit, and the word fission literally means to split apart. That's what it means. So maybe if you know your geology a little bit, you might know the term fissure. A fissure is a big crack in the ground because it's split. The ground is split. It's a fissure. So fission is splitting. So how does that work? Well, first of all, you've got to have an atom here. Let me shrink this up a little bit. Boom. We've got to have an atom. Right here we have our unstable atom, uranium-235. And it starts with force. You have to have something traveling really super fast to hit that atom. And with enough force, you can disrupt the stability of the atom, and that's what we're seeing here. So we shoot a neutron at it. Somehow this neutron got enough energy, got enough kinetic energy to go shooting through space or shooting through the room or shooting through wherever, and it hits this uranium atom, and that uranium atom splits. And in this case, it's splitting into two different atoms. It's splitting into krypton-92 and barium-141. And that's what this is about. Now, when that happens, it also releases a ton of energy. Some of that energy is going to be kinetic. Some of that energy is going to be radiation waves. Some of that energy is going to be thermal, perhaps, because these molecules are rubbing up against other molecules. But we got a lot of energy leaving this particular event. Now, in addition to these two smaller atoms and a bunch of energy, we also get neutrons. And in this situation, we're getting 3 neutrons that are also shooting out with a bunch of kinetic energy. So there you have it. That's fission. Well, not quite. There's a little more to the story. Because these neutrons, if they hit another unstable element, well, it can happen again. So now we've got these neutrons hitting other uranium atoms. That's because we rarely ever find one single atom of something. Usually we've got a block of something, we've got a material, and that material is going to have billions, if not trillions of atoms in it. So each time one atom splits and releases and makes 2 smaller atoms and releases some neutrons, you can have other unstable atoms hit by those neutrons, triggering the event again. So now we've got this uranium-235, this separate uranium-235 atom getting hit by the neutron that got split off from this earlier event, and we now have our second generation of fission. We have xenon-144, strontium-90, cesium-144, and rubidium-90. And then this can keep going. Those can split, and in fact, this can become quite crazy. As you can see, it will keep going until there aren't any more uranium atoms to hit. And that can be a lot. And every single time that happens, a ton of energy is being released. So this is a really good way to get a lot of energy pretty quickly. So how do we use that? Well, we have used it historically for bombs. We have made atomic bombs. And we have used it historically for nuclear power. So when we have our nuclear power plants, they are doing these kinds of things in a contained environment. And it creates a lot of energy, a lot of thermal energy, which we use to heat up water, which creates steam, which then rises, and it turns turbines, which generate energy. You don't need to know the details of how the nuclear power plant works. You just need to know that we are using this kind of event and containing it so that it can be useful to us. We're getting the energy out of it and transferring it to what we need it to be, essentially electricity. So, I hope this helps. Struggle well.